from where we stopped yesterday. Today we stop at the Wednesday work, and today we are going to begin. I want us to finish the first week. So let's look at the quiz that we had on Thursday. Now here, the first question was a very easy one, but some of us were not able to answer this. Kerosene moves up the wick of a lamp. Now here, they were just trying to look at a kerosene is a liquid, okay? So it just behaves like water, the same way water moves up the soil. The mechanism that water is using to move up the soil is the same mechanism that kerosene also uses when it is moving up the wick. So we said that the movement of water up the soil is called capillarity. So the answer here, I expected the purpose right here, the capillarity as the answer. So you check on your work and ensure that that work is done. Look at experiment number 2. There was an experiment, there was a diagram that was drawn there, and then they were asking you that in that experiment, what do you think that those pupils were trying to demonstrate? Now, if you look at that diagram, I've drawn this so that you can see exactly what is in the diagram. Now, if I keep on telling you that if we have a bottle or a glass, if it is an empty container, you should know that that bottle or that container is not empty. The glass there is full of air. Therefore, there is air in that glass. Even though there is no water in the glass, but the glass is not empty. That glass is full of air. So this, if you look at that diagram, you can see I've written there air is inside and there is no water. Now it means that this glass was full of water, and therefore there is nothing more that could be added because it is already full with water. I mean with air. Okay. So these pupils were just trying to demonstrate, or they were trying to investigate an experiment that is finding out that air can occupy space. So inside this glass, already the glass has been occupied by air. That's why water could not find its space in. So I expected you to write that air occupies space. That was the experiment that this class were trying to investigate. Let's look at the second question. Define the following terms. Define the following terms. The first one was mass. You see that mass is the quantity of matter in an object. Most pupils were only writing the quantity of matter, just like that. When you say the quantity of matter, you know that answer is incomplete, and therefore I cannot give you the right, I cannot give you a mark. You must say that mass is the quantity of matter in an object. Volume, you say that volume is just the space that is being occupied by an object. Okay, and just to remind you about the mass. Mass is being measured in grams. Okay, you should know this. Mass is being measured in grams. That is the standard measuring unit. Though we also have other measuring units, but the international standard measuring unit for mass is grams. When it comes to volume, volume is the space occupied by an object, and the SI unit or the international measuring unit for volume should be cubic centimeter. Okay, I may not write it there, SI, but you should know that the volume is being measured in cubic centimeters. Then we have density. Density is a measure of mass per unit of volume. Okay, it is the relationship of mass and volume. And when you are asked to find density, you will see that density is equal to mass over volume. And you can see the SI unit for density is grams per cubic centimeter. So once you see that, you can see the relation between mass and volume. I expect you to write that. Then we have weight. Weight is the gravitational pull of an object. Not heaviness. Please don't talk about heaviness. The word heaviness, that one can only be used in lower classes. But once we are in upper classes, don't talk about heaviness. Talk about gravitational pull of an object. And you must know that the SI unit or the international measuring unit for weight is Newton. Okay. Don't say kilograms. Kilograms is for mass. So we must know those two things. Okay. So the SI unit for weight should be Newton. Don't forget about that. Then we have number 4 was asking that weight is measured in, you must know that weight is measured in Newton. That's the way I've said that the SI unit for weight is Newton. Therefore, weight is measured in Newton, while mass is measured in grams. Don't talk about kilograms or tons. Okay? Those kilograms and tons, those are just other measurements. But the first one, the international standard measuring unit for mass is grams. Let's look at number 5. The process by which water vapor changes to liquid. I think this we looked at yesterday, and there's no need of repeating that. It is the condensation. This is the process whereby gas change back into liquid. We call it condensation. Water boils at a temperature of, that question was there, but you must know that it is only pure water that boils at 100 degrees Celsius. It should be Celsius. Huh? It should be Celsius. It is only pure water, not any other water, because impurities will lower the boiling point. But if that water is pure, it will boil at 100 degrees Celsius or centigrade. But if we have some impurities, like don't expect dirty water to boil at 100 degrees Celsius. It is only pure water. Then number 7 was asking about state 3 measuring units. State 3 units of measuring mass. I've said that the first one is grams. Then from grams, we can go to, now we can derive kilograms and tons. So those are the 3 other measuring, the 2 other measuring units apart from grams. We have kilograms and tons. Number 8 was asking, now which state of matter expand most when heated? I think this is a repetition of the question that we did yesterday. And there I have written them in order, from the one that expand most to the one that expand least. So we have gases expand most, while solid expand least when heated. Let us take a look at Friday work, and this will end the our week 1 revision. What is contraction? This is a very simple question that class 7 was supposed to get, but others did not do it right. So we said that contraction is just the decrease of a substance in volume when a substance reduces in volume or in size. Remember, volume and size is the same, okay? So a decrease of a substance in volume or size, that is contraction. While the increase of a substance in volume or size is now the expansion, okay? Now, number 2, name 2 liquids that is used when making thermometer. We only have 2 liquids here. We have alcohol and mercury. I know one may be asking why. We have down there, I've said that the 2 liquids that are named above there, they are able to expand or contract under little change in temperature. So alcohol and mercury, they are able to detect any little change. It means that when there's little increase in temperature, they are able to expand. If there's little change in temperature, maybe a reduction, they're able to contract. So because they respond very, very fast to changes in temperature, being that they're able to expand and contract, that's why they're used when making thermometer, because thermometer is all about expansion and contraction. Okay, that's why alcohol and mercury become, let's not talk about water, because we have said, remember, water takes a long to expand. Okay, so alcohol and mercury are the ones that are effective. Let's look at number 4. State 4 is of maintaining a simple tool. State, am I in the, okay. Number 3, let's look at number 3. Work is done when force moves on an object. This was a question that was just having a dash. Dash is done when force moves on an object. We talk about work, okay? Remember, When we talk about work, we say that for one to realize work done, there must be application of force, and also there must be realization of distance. Okay. So when you talk about force and distance, or force and movement of an object, we are describing about work. Okay. So work is being affected by force and also the movement of an object. Some of us got this question. Some of us were not aware, but I think now you can do that question. Number 4, give 2 reasons why simple tools are maintained. Give 2 reasons why simple tools. Why do we need to maintain our simple tools? 1, for effectiveness, or for them to work effectively. For durability, meaning for them to last longer, and also for safety. Safety to who? Safety for the people that are around. Okay, so we have to maintain them for effectiveness, for durability, and for safety. Let's look at question number 5. State 4 ways of maintaining simple tools. I've given you there several ways. 1, use the tools for the right purpose. Cleaning the tools after use. Oil the metallic parts to prevent rusting, and also oil the movable parts to reduce friction, because you know that friction is causing what? Wear. Okay, so to avoid that wearing of tools, ensure that the movable parts are well lubricated, or you apply the oil. Replace the broken parts, fitting the handle firmly with metal parts, sharpening the cutting edges, and then proper storage. Why do we do proper storage? We are doing proper storage to ensure that our tools are safety. Okay, our tools provide safety to the people. Okay, don't just put the panga just next to the door where people are using when they're entering into the house. People, because no, some of these tools are very sharp and they may cause accident when not stored properly. So we are storing them properly to ensure safety to the people, and also to avoid theft. They can be stolen if you just put them there, to ensure long lasting, at least to keep them where they will not get damaged. We have harsh weather conditions, we have other things that may make these things to become very reckless. Okay, so to ensure that they last long, we have to keep them safe. Then lastly, to make room tidy, tidiness of the room. Okay, don't just put these tools anyhow. At least arrange them somewhere, have a special place where they should be kept, so that at least even when one comes into the house, at least they can see the room or the house is well arranged, and there is no such things that can make one become annoyed. Number 5, write down the differences between homogeneous solution and heterogeneous solution. Now we say that homogeneous. Homo means uniform, okay? So homogeneous is a solution formed by mixable liquids. For example, you have water and you have spirit. When you mix these 2 liquids, they are going to mix. Therefore, that solution formed when you mix these mixable liquids, we call it homogeneous. While heterogeneous is a solution formed by immixable liquids. For example, take paraffin and water, put them together. These 2 liquids will never mix. They are going to form 2 layers. Therefore, we call it heterogeneous solution. Finally, and that was the last question, how many stones of 1 kilogram will balance 4,000 grams? This one was just like a mathematics, and I expected people to get this, but not all of us got it. This, okay? But this is what you're supposed to do. You're supposed to first give the relationship between kilograms and grams. You say that 1 kilogram is equivalent to 1,000 grams. And therefore, you find how many kilograms will be equivalent to 4,000 grams. If you do that work the way it is done there, you will agree with me that you are going to have 4 kgs. So if 1 stone was 1 kg, then how many stones do you need to give you 4 kgs? You need 4 stones. So the answer was 4 stones, and there was no any other answer. I want to stop there. We have come to the end of week 1 revision. Let's meet in week 2 tomorrow. Have a blessed day.